It's on.
What's your homecoming theme?
Space.
Oh. No, it's out of this world.
It's space.
But it's cooler than that. It's supposed to be cooler than that.
What
But
do you dress up?
The dress up day today is decade, so everybody's dressed like a different decade.
I told you.
Oh.
Wait, keep going. Wait,
Well, what other dress up days do you have?
Jammy.
We had Pajama Day yesterday for Space Jammies, and then today is Decade Day, and tomorrow is NASA, or Red, White, and Blue.
You forgot Thursday.
And then Blue and Gold Day, because, you know, we're the goats.
Okay. I thought it was
Still on.
Hey, there's my lovely students. How's everybody today?
Good.
Thank you for your patience. Let's see how we've got the camera set up. Can you guys see me? I don't see me. Can you see me yet? No? Okay. Let's see here. No? Okay. Now do you see me?
No.
I see.
Okay, great. Well, we'll figure it out. I'll let me get the lesson loaded up. All right, so we're gonna go to we're gonna go to 2.2. All right. So, any questions, comments, concerns before we get started today? So I thought it was dress up day in Joseph City. Why does Avery look so goofy? Anyway.
We can only see about half of your face.
Yeah, probably like the bald half, but we'll figure it out. All right. So let me.
Where's the support? I compliment your tie every day, Jeff.
Oh, okay.
It's
Thank
deep.
you.
It's deep.
All right. I guess it's like history dress up, right? So you're like 1880s or something?
Something like that.
Something like that. Okay.
Technically, I'm Amish, but
Oh,
since
Amish.
they're around in all generations, so I just say I'm a farmer in the 1930s.
All right. That'll work. Okay. What are we doing here? Okay. Oh, I thought that was. Okay. All right. Well, I do appreciate your patience. Oh, wait, I'm not. You guys aren't in the calculus class. I'm like ready to teach you guys calculus today. I don't know. Are you ready? Okay. So 2.2. Let's see. Okay, now we can. Please. Okay, so if I stand over here by the board, now can you see me? Yeah? Okay, good. Okay, here we go. So 2.2, so we're talking about linear equations in two variables. Oh, so before I forget or whatever, let's just remind ourselves that the quizzes that we take tomorrow are going to be, let me make sure we got this right, 1.7, 1.8, and 2.1. Yes? Okay. All right. So, linear equations. So, I've kind of highlighted the word line here. So, basically, we're going to be talking about lines, graphing lines. All right. So, recognizing linear equations in two variables. We'll talk about intercepts, horizontal and vertical lines, finding intercepts on the calculator. So, we'll find them by hand. And then we'll find them on the calculator. Okay? All right, recognizing linear equations in two variables. A linear equation in two variables is an equation that can be written in the form ax plus by equals c. That's what we call standard form. All right, so let's say if what we're going to do is basically look at these and just say, I mean, what do you think? Give me thumbs up if you think it's linear, thumbs down if you don't, if you think it's not linear. Okay, so the first one, A. Okay, so the vote seems to be no. The answer is yes, it is. Okay, so sometimes it may not look linear, but if you were to distribute and simplify, you could get all the x. So if you can write it as ax plus by equals c, then it's linear. Okay, how about the next one? Thumbs up for yes, thumbs down for no. All right, I'm getting kind of a mix. I would say most people are saying no. The answer is yes. That one is also linear. Okay. All right. So what you would do here is distribute. Oh, I see why you would think it was not linear, because the x's cancel. All right. But so when you go back, let's go back to the standard form. See, when you have ax plus by equals c, you can have either the a or the b be 0, but not both. So if you have no x's, that's okay. It's still linear, or no y's, but you have to have one of them. Okay? Well, all right, so the next one. What do you think? Linear, not linear. Come on, Holbrook, you guys need to vote a little bit. Just, it's okay. I mean, the answer is no. That one is not linear. Okay? Now, let's see if we can figure out why that one is. Let's look at, let's see, do we have C? No. A. Wait, that one is linear. You said no. So that one is. Maybe we, maybe this was just our guesses. Okay. All right, so let's go to this one. For D, what do you think? Yes or no? The answer is, oh. The answer, okay, so, okay, this must have been the vote of the last class. This one is not linear, and I'll tell you why. Is that, see, if you combine all the x's, we get 3x plus 3x. Over here, the x's are going to cancel, and the y's are going to cancel too. And so this one is a no. This one's not linear if everything cancels. Okay, so what about E? Is E? All right, we got everybody, it seemed like we've got all no's on that one. And that's right because of the cubed. All right. How about this F? Is that linear? It's a little tricky. This one actually is linear because the x squareds cancel, and so you just end up with x and y. So, okay. All right.
Mr. Strong?
Yes.
And a linear equation, it can have any number of exponents, right?
No, it can't have exponents. It's just,
Can't.
just ax plus by. If it has x squared, it's not linear.
Oh, okay.
So, okay. So I'm glad you asked that. I must not have been clear on that. Okay, so now on your paper, let's see here. The first practice problem is where you're You're guessing whether those are linear. So let's go through those. So on 2, 2. Actually, I guess we did those. We did some of those anyway. Go ahead and write down if you think those are linear and why. We'll go through. All right, so this one, when you simplify and get everything together, you can write this as 2x plus 5y equals 3. So when you're actually doing these type of questions on a test or a quiz, this is what you need to do, is to distribute, combine like terms, whatever, so that you can actually put it in the form ax plus by equals c. And then when you put it in that form, then you know it's linear. Okay? All right. So with this one, in order to get it in this form, what do you need to do? In order to put it in standard form, what do you need to do to this equation here? All right, well, you need to get rid of the fractions, okay? So what would I multiply by to get rid of the fractions? Okay, 15. So some of you signal that. So if we multiply everything by 15, then we get 5 times x plus 2 minus 15y equals y times 3. And then combining or distribute and get the x's and the y's together. So we have 5x and then negative 15y minus 3y is negative 18y equals negative 10. Okay, so that's linear. We can write it in that form. All right, so why is this one not linear?
Because of the cube.
Because of the cube. So this one's not linear. Okay. All right, any questions on that? All right, next, intercepts. The point where the graph crosses the x-axis is called the x-intercept. And the point where the graph crosses the y-axis is called the y-intercept. Okay. Okay, so, all right, so in order to find the intercepts, to find the x-intercept, you plug in 0 for y. So when you plug in 0 for y, you'll get 3x minus 4 times 0, where that term goes away. So 3x equals 12, so x is equal to 4. All right, then to find the y-intercept, you plug in 0 for x. So then the first term here will go away. You'll get 3 times 0 minus 4y equals 12. Negative 4y equals 12. So y equals negative 3. So then to graph the line, so to me this is way easier than doing the T-chart method that we showed before on Thursday. Because in this method, you're just finding those 2 points, the intercepts. So the x-intercept is 4, so on the x-axis, you go to 4, put a dot. The y-intercept is negative 3, so at negative 3, you put a dot on the y-axis, and then you draw a line connecting those two. Okay? All right, so let's have you do practice 2. So you find the x and the y intercepts, and then plot the line. All right, so Seth, what is the x-intercept?
Do 0.
Okay. X-intercept is 2. So 2, 0. Very good. All right, Raylyn, what's the y-intercept?
0, 5.
0, 5. Very good. So then when you graph those 2 points, 2, 0 and 0, 5, then boom, you've got the line. Okay? Great job. Any questions? Okay. All right, part 3, horizontal and vertical lines. A horizontal line is represented by the line y equals a constant, y equals b, and it has a y-intercept of 0, comma b. So if the line doesn't have any x's and it's just y equals a constant, then you know it's a horizontal line. Okay? So if we were to simplify this, and we ended up with just y equals 7, then you would go up to 7 on the y-axis and then draw a horizontal line. So it's y equals 7 is a horizontal line, and the y-intercept is at 0, 7. Okay? All right, so let's have you try practice 3.
So Jeff, we don't set x equal to 0 on this, right? We just simplify it and combine like
Well,
terms?
yeah, if you simplify it, the x's will drop out. All right, so Anna, what did you get?
I got 4.
So, anything else like an x equals or a y equals?
Y
or something
equals-
like that?
Y equals 4.
Y equals 4. Okay, so so y equals 4, and so then to graph that, you'd go up to 4 on the y-axis and make your horizontal line. Okay. All right. Any questions on that? Okay. Okay, a vertical line is represented by the line x equals a constant, x equals a, and has an x-intercept of a comma 0. All right, so let's say I had 5x equals 0. Well, when I divide each side by 5, I get x equals 0. So I would go to 0 on the x-axis and draw the vertical line, which happens to be the y-axis. So its equation is x equals 0. So if it's x equals a constant, then that's where it crosses the x-axis and you draw a vertical line. All right, so go ahead and try that one. All right, so Jocelyn, what is the equation simplified to?
Would it be x equals 2.5?
X equals 2.5 or 5 halves, however you want to write it. And so to graph that, you go to between 2 and 3 on the x-axis, and then make your dot, and then a vertical line that goes through that. So x equals a constant is a vertical line. All right, any questions? Okay, so now finding intercepts on the calculator. So you graph the equation using the calculator. We've done this before, where in the calculator you have to have it solved for y. So it's got to be y equals. So if it's not solved for y, you have to solve it for y first before you put it in the calculator. All right. Then to find the the y-intercept, you use trace and then 0 and enter. And then to find the x-intercept, another name for an x-intercept is a 0. That's what your calculator calls it. So there you use second calc 0, and then you go to the left of it, to the right of it, and enter, enter, enter. You press enter like 3 times. So it should be left, enter. Another enter there. And then right, enter, and then another enter. Okay? So now it doesn't make sense the way it's written, I get it. But we'll go through it, and I wanna just do it up on the board, and I just want you to watch. Okay? Just want you to watch, and then we'll have you do one to make sure that you understand what's going on. So let's please have the calculator here. Okay, great. All right. So the first step is to solve it for y. So in this case, I need to add 2x and subtract 6 to both sides to get that. All right? Now, I take that and I've got to start off with putting that in the calculator. Let's see here. Okay. So y equals 2x minus 6. Okay? Now, typically you want to have things in standard viewing window. So if it's not, then press zoom standard. Okay? Now, to find the y-intercept, you press trace, and then it actually popped up already. Because otherwise you press 0 for x and press enter, and then it'll tell you where this is the y value, y is -6, and so it even shows you on the graph where your y-intercept is at 0, -6. So you press trace, okay, and then 0. Okay, now to find the x-intercept or the 0, you press second, calc, 0. And it'll come up and say it needs the left bound. So what we need to do is give it a point to the left of the x-intercept. Okay, well, where it is right now is to the left of it, so I'll just press enter. But then it says it needs a right bound. So what I have to do is arrow over to the right or past the x-intercept here. So now I'm to the right of it, and so I press enter. Okay, now it says guess. Now, typically, we're never going to need to worry about the guess. Just press enter again. The reason why they have that is in case you have more than one intercept within your interval, and we're not going to do that. So just press enter again, and so then it tells you the 0 or x-intercept is 3, 0. Okay. All right, so any questions before I have you do one? Okay, so I want you to do practice 4. So put it in the calculator, find the y-intercept, the x-intercept, and graph it on your paper. All right, so Desiree, what's the y-intercept?
I got 0, 5.
0, 5. Okay, good job. Let's see, so. Okay, so the y-intercept is 0, 5. Any questions on that? All right, Sierra, what's the x-intercept?
2.5.
Okay? So the x-intercept is at 2.50. And then when you graph it, you should see that on your calculator. Okay? And hopefully you're able to find those intercepts by hand or using the calculator. Okay? All right, any questions on any of that? Any questions on 2.2? All right, well, let's go ahead and just, I just want to take a couple of minutes and just do a little intro into 2.3. Okay, so 2.3 is what's called forms of linear equations. And really the main form that we're going to focus on is the slope-intercept form, okay? The slope-intercept form of a line, okay? So in this section, we start off with the slope formula and give the formula on how to find it. The slope-intercept form and use that to graph a line, and then the point-slope form of a line, and we use that to find the equation. So the first formula is to find the slope, the second one is to find the graph, and the third one is to find the equation, okay? So the first one, to find the slope of a line. All right, so this is the formula here in the box where we have m is equal to y2 minus y1 over x2 minus x1. Now, some people will just call the difference in y's over the difference in the x's. And this little triangle here is actually the Greek letter capital D for difference. So delta y over delta x just means the change in y's over the change in x. Some people also call the slope the rise over the run. And that's basically the change in y's over the change in x. The rise is the change in the height, and the run is the change in the width. Also, if we solve the linear equation for y, like we're putting it in the calculator or whatever, if we get y by itself, the number in front of the x over here is the slope. And so if you don't have the slope already, that's an easy way to find it, is to just solve the equation for y. Okay? All right, so let's look at, well, actually one other thing here is that depending on what book you use, they might have the subscripts different. So instead of y2 minus y1, they might have y1 minus y2. And really, it doesn't matter. Whichever point you start with, though, with the y's, you have to start with that point with the x's. See, what would be wrong is if you started with the first point with the y's and the second point when you're subtracting the x's. Then you get the sign wrong, okay? So you just have to be consistent and you'll be okay. All right, so let's say I wanted to find the slope of these 2 points. So I would do the difference in the y's So -5 minus a -3 over the difference in the x's, 2 minus a -4. All right, so what do you think is the most common mistake that students make in doing these problems?
All the negatives.
Yeah, watching the signs. You got to watch the signs. And you got to make sure they're in the right order. So then change your subtraction to add the opposite. So -5 plus 3 over 2 plus 4. And so then you get -5 plus 3 is -2 over 6. So that would be -1/3. So you do want to simplify your fractions as much as possible. Okay? All right, so go ahead and do the first slope problem there under practice 1A. All right, so Hannah, what'd you get?
Four over 7.
4 over 7? Yes, because if you have two negatives, see, depending on how you did it, you either got 4 over 7, -4 over -7, but then when you simplify that, you get 4 7s. Okay, so great job on that. Any questions? Okay, now if you all right, let's go back to the second one here. Okay. All right, so let's say I wanted to find the slope of those two. No, that's not what I wanted. Oh, yeah. No, that's not what I wanted. All right, just go ahead and do the second one there on your paper. All right, so Avery, what'd you get?
I believe it's 0 because I got 0 over 3.
That is correct. Okay, and I appreciate the fact that you said 0 is the answer. Okay, do not leave your answer as 0 over 3. Because 0 over 3 is equal to 0. Okay, so this has a slope of 0. Now, so horizontal lines, which can be written in the form y equals b, have a slope of 0. So we talked about horizontal lines have a slope of 0. All right, vertical lines, which can be written in the form x equals a, have an undefined slope. Okay, so it turns out, I remember when I first started teaching in Utah, when my students would say, I'm like, what are you doing this weekend? And they would say they were hitting the slopes. It turns out that they weren't doing math, believe it or not. When they say they're hitting the slopes, they're actually not doing math or skiing. So if you imagine like going up a mountain is like a positive slope. And down a mountain is a negative slope. So we'll talk about that more. A horizontal line, like here, that has a slope of 0. So that's like your cross-country skiing. Okay? And then there are actual idiots that ski off an undefined slope. Okay? A vertical cliff. Have any of you ever done that? If it's snowboarding or whatever. Anyway, there's actually guys that will wear parachutes or use a hang glider or do crazy stuff. Anyway, undefined slope is a vertical cliff. Don't ski off of that. Okay. So let's say I wanted to find the slope of this line. Okay. I don't have any points, but if I solve this for y, okay, then the number in front of the x is the slope. Okay. Now, if I have a just a y equals, let's see, no, okay. Well, let's see if you can do these two. So find the slope of each of those, and we'll kind of finish up with as we finish that page. All right, so Sierra, when you have that first slope, let us know.
-4/3.
-4/3 is correct. So because it's the number in front of the x, okay, when you solve it for y. And the last one here for today, let's go to Naomi.
It's undefined.
Yes, excellent, because it's x equals a constant. So when you have x equals a constant, that's a vertical line, so its slope is undefined. Great job, Naomi. Great job, Sierra. All right. So that's it for today. Remember, we have quizzes tomorrow, 1-7, 1-8, and 2-1. Any questions before we drop? All right, you guys have a great day. Thank you for being patient with me today. Hope you have a good one.